The national grid. The national grid is a system of transformers and cables that connects power stations and consumers around the country. This means that if your local power station is out of action or is unable to cope with demand, electricity can be transferred from other power stations. Power stations are often a long way from the consumers they serve, meaning the electricity needs transferring over very long distances. Considering the power transfer required, electrical power is given by the current multiplied by the potential difference. Therefore we could use a large current and a low potential difference. We could use a low current and a large potential difference, or we could use something in between. The transmission cables themselves will be heated by the electricity passing through them. The power of this heating is given by current squared multiplied by resistance. If we want to transmit 50 megawatts of power at a potential difference of 230 volts, that's the potential difference we receive in the home, through cables with a resistance of 200 ohms, well, the current we require is given by the power over the potential difference. Putting in the values means a current of 2.17 times 10 to the 5 amps. So the power produced as heat in the cables will be given by current squared times resistance, and this comes out at a massive 43.5 megawatts. That's nearly 90% of our power being lost as heat in the cables. However, if we could transmit the power at 400 kilovolts, then again the current is given by power over potential difference, but now that comes out at just 125 amps. So the power produced as heat in the cables now is given by current squared times resistance, but this now comes out at just 3.13 megawatts, now just around 6% of the power we're transmitting. For this reason, electricity is distributed around the country at very high voltages, as this diagram will illustrate. A power station produces electricity at around about 25,000 volts, but this is immediately passed through a step-up transformer, coming out to pass along pylons at around 275,000 volts or even 400,000 volts. This is known as the supergrid. As the electricity comes close to built-up areas, it would enter a step-down transformer, coming out again through lower pylons at around 132 kilovolts. Another step-down transformer could see electricity being given to heavy industry at 33 kilovolts, and also passing at 33 kilovolts to other step-down transformers, to come out for light industry at 11 kilovolts, and also into other step-down transformers, also at 11 kilovolts, before finally being distributed to homes and domestic users at 230 volts. These final step-down transformers will be within a few hundred meters of the end user. You may have seen one near your house.